Hello friends. Today on the channel is a review of a real assistant for your smart home and other electronic devices. We will get acquainted with a UPS that operates from two 18,650 batteries and can output voltage of 5V, 9V, or 12V. I am testing the 12-volt version, and this is an excellent choice for backup power for such devices as smart home servers, routers, and other devices that often require 12V, one of the most common voltages for such equipment. This is really a budget solution. For literally $2, you get a device that can provide stable backup power for your equipment. If you have power outages or want to create a backup power system for your equipment, this UPS can be a great choice. It provides automatic switching to batteries when power is lost, so your device will not be left without electricity even when the mains is off. The device supports battery charging via the Type-C port, which allows you to quickly restore energy, and the built-in protective functions guarantee safety during operation. Today we will take a detailed look at how this device works, look at its circuitry, test it under real loads, and evaluate how effectively it copes with the task of uninterruptible power supply for your devices. So if you are interested to know how it all works and how this UPS can help in organizing backup power for your smart home or other equipment, stay tuned, it will be interesting. Specifications. Type of device. This UPS is a DC uninterruptible power supply that provides stable power for various devices even when the main power source is disconnected. Input voltage. Accepts standard 5 volts, which makes it easy to connect it to most chargers and power sources. Output voltage. Depending on the model, the device can provide output voltage of 5V, 9V, or 12V, which makes it a universal solution for a variety of devices from routers to low-power servers. Connectors. For connecting the power source, there are plus and contacts for soldering or USB-C, and for output, contacts for soldering, which allows customizing the connection for specific tasks. Maximum power. The device is capable of delivering up to 15 watts of power in nominal mode, with short-term peaks up to 20 watts, which is enough to power most low-power devices without loss of efficiency. Batteries. 1 or 2 18,650 lithium-ion batteries are used for operation, which provide long operating time and fast charging. Size. The compact size of the device, 88 by 41 by 22 millimeters, allows easy integration into various systems without taking up much space. When you receive this UPS, it is packed in a simple anti-static bag. This is quite a standard solution, as such packaging protects the device from possible damage associated with electrostatic discharges. The package indicates the version of the device. In my case, it is a model with 12-volt output, but there are also versions with 5 and 9-volt outputs, which allows you to choose the most suitable solution for your needs. Now let's look at the board itself. This is a compact but powerful device that is essentially a miniature DC uninterruptible power supply. The board is made without unnecessary elements, and it is quite minimalist, which makes it suitable for use in a variety of projects. One of the notable solutions is the lack of a case. It is important to understand that without a case, the board looks like an open device, and if you need to protect it, you will have to pick up a case yourself or even print it on a 3D printer. This is of course not critical, but for those who plan to use the UPS in conditions where it is important to protect the components, this point should be taken into account. There are clear labels on the board, however, made in Chinese, but they do not complicate use, since for each version of the device at the bottom important data are indicated. For example, in my case, it is DC 12 volts, which clearly indicates the nominal voltage for this particular device. This is quite convenient if you use several devices of different types, as you can quickly identify the desired model. On the back of the board, there are contacts for connecting 18,650 batteries. There is a double slot here, which gives the opportunity to install either 1 or 2 batteries. When connecting 2 batteries, the capacity of the system increases, which will give more operating time of the device when the main power is turned off. The board itself is designed to neatly place the batteries and efficiently use them for the operation of the device. As for power connection, the board supports 2 options. You can solder wires to the contact pads for supplying 5V input voltage, or use the standard USB-C connector, which significantly simplifies the connection and speeds up the charging of the device. The specification states that through this connector, inductor, the device can receive up to 5 amps of current, which guarantees fast charging and stable operation of the device even under load. The output contacts are labeled as UPS plus and UPS and provide the ability to select the output voltage at 5V, 9V, or 12V, depending on the model. This allows adapting the UPS for different types of equipment, from routers to surveillance cameras. In case of loss of external power, the device automatically switches to battery operation, which guarantees uninterrupted operation of connected devices. The size of the device board is compact, only 88 by 41 by 22 millimeters, which allows it to be integrated into various systems without taking up much space. But despite its compactness, it is powerful enough to provide stable power for low-voltage devices. It is important to remember that when using this UPS without a case, the device will be vulnerable to external damage, and for long-term operation, it will be useful to take care of its protection. Circuitry. Battery charging block. The first important component is the charging controller, which manages the charging process of lithium-ion batteries. The board uses a chip labeled 4056B2403D, which is the classic TP4056, a popular controller for charging lithium-ion batteries via micro-USB or Type-C. Functions of the controller: it manages the charge of lithium-ion batteries. The cell voltage should not exceed 4.2 V per cell. It controls the charging process, including stopping charging when the battery is fully charged. Next on the board, there is a group of transistors, Q1, Q4, labeled A19T, which are most likely NPN transistors or N-channel MOSFETs. These components work in DC-DC converter circuits and switching circuits. Simply put, they control when to connect or disconnect the battery from the system, depending on the charge level. This is critically important to ensure the correct operation of the uninterruptible power supply to avoid overcharging or deep discharge of the batteries. The second is the voltage boosting block or DC-DC converter. It is responsible for boosting the voltage from the battery level of 3.7 volts to the required values, 5V, 9V, or 12V. This is done using the popular XR2988 chip labeled XR2988C, which is a step-up converter. Main characteristics of XR2988. Input voltage from 2.5 to 5.5 volts. Suitable for working with lithium-ion batteries. Output voltage from 3 to 12 volts, which gives flexibility for different applications. Output current up to 2-3 amps, depending on cooling. For a 3-amp load, a heatsink needs to be installed. Conversion frequency up to 1.2 MHz, which allows efficient voltage conversion with minimal losses. Binding of the XR2988 converter. Inductor 2R2. This is an inductive element that is used to smooth ripples and stabilize the output current. The inductor is rated for currents up to 3 for A, which is ideal for powering low-power devices. Capacitors 220 microfarads, 16 volts, 4 pieces are used to filter the input and output voltages, eliminate ripples, and make the power supply more stable. Schottky power diodes SS54 Schottky 5A. These diodes provide protection and stable operation in rectifier circuits, preventing reverse current and possible short circuits. With the help of this converter, the device can stably provide output voltage, which makes it suitable for working with various devices requiring power from 5 to 12V. The third is the lithium-ion battery protection block XB7608. This block is responsible for protecting the batteries from dangerous conditions such as overcharge, overdischarge, overcurrent, and short circuit. For this, an integrated XB7608 chip is used. This is a chip that performs several protection functions combined in one package. What XB7608 does: controls overcharge protection when the battery voltage exceeds 4.28 volts, protects against overdischarge when the battery voltage drops below 2.4 to 2.5 volts, protects against overcurrent if the current flowing through the battery becomes too high, protects against short circuit, which prevents device damage. Automatic recovery: if protection is triggered, it restores normal operation of the device after removing the load or applying charging. Why are there two of them? The board provides for connecting two 18,650 batteries in parallel, which increases capacity and current. Each battery is protected by its own XB7608 chip, which allows more efficient management of the operation of each battery. Function of Schottky diodes SS54. These diodes work to protect against reverse current and help provide proper isolation between the batteries, the charging input, and the power output. This ensures that when external power is available, it goes directly to the load and when it is disconnected, the batteries are connected. The principle of operation of the protection system. Each battery is connected through its own XB7608 protection. If one of the batteries goes beyond safe values, for example, overcharges or overloads, this chip disconnects the battery to avoid damage. The load is connected through Schottky diodes, which allows the device to work correctly in uninterruptible power mode. Thus, parallel connection of batteries not only increases capacity, but also increases output current, providing stable power to connected devices. Light indication block. The light indication system on the board consists of two LEDs that serve to display the operating status of the device. These indicators will help you always be aware of the operation of your UPS. Red LED top right of the board. This LED is always on when the uninterruptible power supply output is active. That is, if the battery is connected and the device is in working condition, this LED will indicate that power is being supplied to the connected equipment. This is a simple indication that informs that the device is working and ready for use. Blue and red LEDs bottom left of the board. Here we see two LEDs that signal the process of charging the battery and its state. The red LED lights up when the battery is charging. This indicates that the device is connected to an external power source and the charging process is active. The blue LED lights up when the battery is fully charged. This means that charging is complete and the battery is ready for use. Such indication helps to easily monitor the status of the device operation and the battery charging process, providing a complete understanding of the UPS status. For testing, I use two lithium-ion batteries with a capacity of 1658 and 1772 mAh. Of course, you can use higher capacity batteries, for example, with a capacity of 3400 mAh. This will significantly increase the operating time of the device without external power. I deliberately chose batteries with a smaller capacity to show the operation of the device at the lower nominal. Initially, I soldered the connector to the 12-volt output because connecting to the contact pads with crocodile clips is not very convenient. This slightly simplifies the testing process. Let's first check whether this UPS actually performs its main function, switching from external power to the battery and back without interruptions in the supply of voltage to the load. I connect a multimeter to monitor the output voltage. At the moment, I have no batteries installed, and as we can see, the output is 12 volts, and the network power indicator LED is lit in blue. Everything works as it should. Now I insert the battery into the slot. At first glance, nothing happens, despite the fact that the battery is not fully charged. The system does not recognize its installation, and the multimeter shows zero current at the output. This is strange because the UPS should immediately start working on charging the battery. I turn off the external power, and the power indicator LED goes out. However, the multimeter does not change its readings, and the output voltage remains the same, 12 and 5 volts. This suggests that the system switched to battery power at that moment. Now I reconnect the external power. And now the UPS recognizes the installed battery, and the LED state changes to red. The battery charging starts. The multimeter also shows that the load current has become non-zero, and the device starts supplying power to the load. Next, I remove the battery but leave the external power connected. The multimeter does not react to this change, and the UPS continues to supply power to the load. The LED is lit blue again, which means that the battery charging is complete or the power is coming from the external source. As we can see, the switching between external power and batteries occurs seamlessly. When the batteries are fully charged, charging will stop, and the load will be powered by the external 5-volt source. This confirms that the UPS performs its main task of providing uninterrupted power. I accidentally tested the device for output short circuit protection. The whole device turned off. After I eliminated the short circuit, the device turned on. Now let's check how the UPS copes with the load at maximum current. For this, I connect a 5-volt power supply with a maximum current of 3 amperes to the input and a load to the output. Let's see how the device handles this and what results we get. First, let's check the maximum load when an external power source is connected. So, the load was 1 ampere. This is a normal indicator for most devices, and the UPS handles this without problems. However, when the load increased, the UPS began to go into protection. This may mean that the 5-volt power supply itself could not cope with the higher current, which also could have triggered the protection on the UPS. At 12 volts and 1 ampere, this is quite a good result. We see that the device works stably under load, which is close to the maximum limit for this device. Now we turn off the external power supply and leave the UPS running only on batteries. The maximum current with such a connection is 1.3 amperes. But as soon as the current increases to 1.4 amperes or higher, the UPS begins to go into protection. At the same time, the output voltage drops several times and recovers, which confirms the activation of overload protection. For such a small device, 1 ampere of current at a voltage of 12 volts is quite a sufficient result. For example, for most modern routers, and even for a smart home server, this current will be enough for stable operation. For verification, I plan to connect such devices and see how the UPS will cope under real conditions. For example, let's take an ordinary old router, not a 3G one, but dual band, and with a USB port, and supply power to it through our UPS. We connect the router, and as we can see, the current consumption is quite small, but it will reach a maximum of 0.3 amperes. The boot indicator started, but if you connect a hard drive, then yes, I agree with you, it will be more than 0.3 amperes. But on average, I roughly calculated when I made guaranteed home power, it's somewhere around 300 milliamperes. As you can see, nothing is connected, there is no external power here, only 2 batteries. Let's connect and disconnect the power, check. We connect the power, the battery charge indicator LED lights up. I turn off the power. The power switches directly to the battery. And thanks to the presence of capacitors, all this happens seamlessly and is imperceptible to connected devices. The uninterruptible power supply is connected only to the batteries. I connect a mini PC based on Soya. Here I have Home Assist installed. The disadvantage of this model is that after a power outage, it is necessary to physically press the button, which leads to turning on the smart home server. Therefore, I strongly recommend to such owners to buy just such an uninterruptible power supply. It is inexpensive. Install the batteries. And you don't have to worry that even now it has a current of almost half an ampere during startup. No problems. The voltage remains stable. The current is constantly changing. It increases, then decreases. And there are no problems with booting. The server boots up, starts working, and you have reserve power for it thanks to such a small box. Let's assemble such a stand. We have power from 2 batteries, and now I have set the battery to 3.9 volts. And the load is set to 0.5 amperes. Let's see how much our load and our uninterruptible power supply can discharge the batteries to, and whether it will turn off. Let's see how many watt-hours it will take. Now I have reset all the indicators here. 0.47 amperes. The power is now 21 volts. Half the power is 6 watts. The battery voltage started to decrease, and I leave it for some time. I didn't quite make it in time, but at the stage of 2.6 volts, the battery disconnect occurs. I connect the power. I specifically chose slightly worn-out batteries. Now you can see for yourself. I gave a small load, already a small one. Here is 2.7, and let's monitor the state of our device. I turn off the power. Everything is 2.5, the protection worked, the batteries disconnect. So the discharge protection is present. Let's see how much we managed to take off. It worked on these batteries for 1 hour 08 minutes. There were only 7 watt-hours. Now let's charge the batteries and see what current it will give us. 5 volts, 3 amperes. And we see that the charge current is 0.76 amperes. We have 2 cells installed. I inserted another cell. The same 0.76 amperes. It turns out 400 milliamperes per cell. Well, I would say this is quite small in our realities. This is a small minus. Let's check directly from the power supply. The same 0.76 amperes. It doesn't matter whether you have 2 batteries installed or 1. 1 will charge faster, 2 will charge with a smaller current. But accordingly, if there are 2 cells, then the capacity will be greater and therefore it will last longer. Now let's see to what voltage our device charges the batteries that we installed in it. After a while we see, for 16, that is, not 4.2, like a full charge of lithium, but a little less. Which is even good, because if you are not going to use the batteries, it is better to keep them slightly uncharged than charged to 100%. This is also a plus for this uninterruptible power supply. Now let's summarize. This is a very interesting and budget-friendly solution for organizing backup power for your devices. The device supports a wide range of voltages, 5, 9, and 12 volts, depending on the version, which allows it to be used for various equipment, from routers and network devices to smart home servers, IP cameras, and GPIO terminals. At an output voltage of 12 volts, the device can deliver up to 1.3 amperes, which is enough in most cases to power routers, mini servers, cameras, and other equipment. At lower voltages, for example, 5 volts, the current can be significantly higher, up to 3 to 4 amperes, but at 12 volts the power limit restricts the current to 1.3 amperes. It is also worth noting that this UPS works absolutely seamlessly. Switching between mains power and batteries happens instantly and is completely invisible to connected devices. The presence of capacitors at the output helps smooth even minor voltage dips, so devices do not reboot and continue operating without interruption. Moreover, when the batteries are fully charged and mains power is available, the connected load is powered not from the batteries, but directly from the mains, which reduces battery wear and extends their lifespan. In this case, the batteries simply remain in standby and charging mode. The device has built-in battery protection. It protects against overcharge, deep discharge, overcurrent, and short circuits. This ensures the safety of both the batteries themselves and the devices powered by this UPS. Charging is done via a USB Type-C port, which is very convenient. You can use any standard charger from a smartphone or even a power bank. Its compact size, 88 on 41 on 22 millimeters, allows the device to be placed anywhere, in a server rack, a network cabinet, or simply hidden behind a router. The only drawback, although it is rather conditional, is the absence of a case. But this is more of a DIY solution, and if desired, the case can be 3D printed or made from any suitable material. Another minor downside is the relatively low charging current, 0.76 amperes for 2 batteries, which is about 400 milliamperes per battery. This is not too much if you often experience power outages and need the batteries to charge faster. But overall, this is an excellent budget solution that fully copes with its task. It is ideal for powering routers, GPIO and terminals, smart home hubs, mini servers, and other low-power devices. You can build such a backup power system for literally a couple of dollars by simply adding a pair of 18,650 batteries to this module. All the product links can be found in the description below this video. There's also a link to my Telegram channel, where you'll find even more interesting gadgets, discounts, useful information about smart home systems, as well as friendly communication and answers to your questions. You'll also find a link to the Smart Home Forum, where topics are organized into sections, making it much easier to find the information you need. And don't forget about our Facebook group. Plus, subscribe to my page on X. I also share interesting updates and collections there. If this video was helpful to you, leave a like. And make sure to subscribe to the channel so you don't miss other reviews and guides about smart and not so smart home systems. That's all for today. Wishing you peace and kindness. Bye-bye, and see you in the next videos.